Hello, I'm Dielsa, and I studied integrated urban development and design at the Bauhaus University in Weimar. This is a brief insight of my thesis titled Measuring Sustainability, an Integrated Computational Framework to Operationalize and Interpret the Performance of the Urban Form using Generative Design Methods. With the rapid urban planning, the need for sustainable development has increased a lot. There are many urban agendas that are fostering the call for a more sustainable development. And this thesis, in response to that, it focuses on three design goals: quantifying urban sustainability in new urban development projects, filtering the information and clustering it in operationalizable format, which is interpretable and easy to understand by all the stakeholders, and to extract knowledge on actionable guidance for designers based on the performance data. To achieve the goals, this thesis presents a computational framework which algorithmically builds a generative urban design model, adjusts methods to quantify urban performance in each pillar of sustainability in real time, and it correlates the input design parameters with the output that indicate the performance. In a nutshell, this is the architecture of the framework, and the beauty of it is that almost all of it works within Rhino and its visual programming language Grasshopper. It is mainly consisted out of three parts: the algorithmic parametric urban model, the evaluation part, where several methods to quantify the performance are elaborated, and the last part, the data analysis, which explores the solution space. The generation of the model happens based on three main input parameters: the floor area ratio, the ground space index, and the street network orientation. Based on the configuration, several design options can be generated. And the best part of it is that all of this can be used in participatory planning processes in an interactive environment, since this framework can be easily connected with augmented reality and workflows. Like here, we can see the urban form and the performance metrics, indicators. And this way, all the stakeholders can have a better understanding of the design, and also having the performance feedback instantly will improve the discussion's quality. And this performance layer, they refer to the social, environmental, and economic dimension of sustainability. An important social factor of equality that depends on the built environment is equal access. Therefore, this study adapts space syntax metrics with demographic data to measure social integration and accessibility to significant quarters of the design urban layout. On the other hand, with the growth of climate change, microclimate analysis is a must in early stages of design. Geolocated wind speeds and solar radiation are the only microclimate parameters that depend widely on the urban planning. Therefore, this study focuses on sunlight hours and wind comfort performance. To have instant feedback on the performance, the research uses pre-trained machine learning models of the CIL to predict its performance. Regarding the economic dimension, this thesis suggests a framework that elaborates upon the tight connection between the economic potential and the time dimension. It puts together a hypothetical economic dynamic model combining existing workflows to understand the resilience of the city as a complex system, and it indicates its economic potential. This framework is applied in the city of Vienna, and while exploring its performance space and the performance data analysis in each indicator in integrity, wind comfort, sunlight hours, system sturdiness, the investment worth potential, the footfall potential, a general rule of thumb can be derived. For example, for a design to perform better in its integrity score, the orientation of the existing streets should match with the new design streets. For environmental analysis, we should have diverse building typologies and keep reasonable proportion and composition of built and non-built area. And aligning the street network with the newly designed streets can lead to places with higher economic potential. This framework can be used to compare the design options by setting also importance weighting to each performance indicator. In this presented case, the weighting was set equal for every indicator, and the best performing design options and the worst one are presented in the right part of the canvas. We can see that the design option 56 performs better in almost every category. However, we can change the weighting based on the challenges that we want to achieve. Anyways, as promising as the framework appears, of course it does not cover all issues related to urban sustainability. Due to the complexity of the urban systems and the quantification methods, more research is needed to quantify the urban performance. Thank you very much for listening. This was a brief overview of my thesis, and for the complete work, please check the PDF in the link below.